Hi physics class, it's me Andy. I'm doing number, oh and Caleb's right there. He's the camera guy. We're doing number 5 for the group project, or group stuff.
Work.
Group work, yeah. So this one you have 2 charges. It's on a number line going from 0 to 5. So they're pretty much 5 centimeters apart. So this one is 3, you're already big. This one is 3.5 centimeters, nanocoulombs, my bad. And this one's negative 1.2 nanocoulombs. So they're placed this far apart, and it's asking where can an electron be placed so that it feels no net force. So we've got an electron here somewhere. We don't care what the charge is of an electron, but it's going to be some distance in between these. So I'm going to write R sub 1 right there. That's R sub 1. We'll be looking for that. You also have an R sub 2. R sub 1 plus R sub 2 equals this distance, so 5 centimeters. So we already have one equation. Then it's asking for force, right? So we want to see, it's going to be doing this. It's going to be pulling in opposite directions. Actually, I did that wrong. Hold on. You have a negative charge. It's going to be pulling stuff towards it, right? And then here you have a positive. It's going to be pushing stuff. Does that even make sense?
So a positive and a negative attract, and 2 like charges repel.
Oh, that's right.
Yeah.
So I guess.
Yep.
So this is going to be.
Right, so
Oh.
that will repel.
So it's going to be pushing this way?
Yeah, they'll be pushing against each other. Yeah, and then the other one will be pushing that way. The one on the far right will be pushing to the left. No, on the negative 1.2, it'll be pushing that way. And then that one, yes.
Huh.
Does that make sense?
Something like that. Either way, you have F sub 1 equals F sub 2. And we can equal those to each other. And from the book, I don't remember what equation number it is, but you can find what an electric force is when you have charges next to each other. So you got F sub 1 equals K, we don't care what K is either, times the first charge, the absolute value of the first charge, times the absolute value of the second charge divided by R sub 1 squared. That's the distance between those two. And F sub 2 is going to equal K times K sub, oh, it's not K sub 2, this is K sub 2. K sub E, my bad. K sub 2 times K, Q sub
Yeah, Q.
E. This is hard. Okay. I did it earlier, no problems. And then you have R sub 2. That's the distance between this electron and this charge over here. Now you say how to equal these to each other. You have K, wow, K times Q sub 1 times Q sub E, the Q of the electron, times R sub 1 squared equals K Q sub 2 times the Q of the electron divided by R sub 2 squared.
And we can do that because there's no net force as stated in the problem.
Yeah, zero net force. If you've taken statics, we're pretty much doing this.
Perfect.
Yeah. So now our K's cancel, and our electron charge cancels. Like I said, we don't care what they are. So we end up with this. Q sub 1 equals R sub 1 squared equals Q sub 2 over R sub 2 squared. So you have these two equations. Then you get to solve for them simultaneously. And you get, let's see, what was it?
Oh.
Yeah, okay, go. R sub 1 equals 3 point, oh crap. Yeah. 3.13 centimeters. And that's number 5.